Firstly, we need to implement the GameBalance component in all actors that we want to change attributes in real time. Let's create a forcing line so we can get that component whenever we need it. It's important to remember that you can also add the component via blueprints. We will also create a function called updateValues, and I will explain shortly what this function is for. I will now show you how this implementation looks in the .cpp file of the class. You just need to follow what is in this example. Note that this delegate is always listening whenever an update properties is called within the component, and triggers a call to the updateValues function we created. This is used to update internal values of a third-party component, such as the speed that is inside the character movement component. I've implemented all of this through C++. It's time to open your project in Unreal so we can proceed with activating the GameBalance component. Let's open Project Settings and search for World Settings. Inside the World Settings configuration, you should select GameBalance World Settings. Before continuing, restart Unreal Engine so that this change takes effect. After that, you need to open the World Settings window of your project and then search for the part where you need to enter the F-name of your table name. Now let's create our spreadsheet that will contain the necessary information for GameBalance to function correctly. In the root folder of your project, create a folder named Data, and inside this folder, create a spreadsheet that will later be saved as a .csv file. In this spreadsheet, the first column should always contain the names of the actors that will have their values changed, always from a BP. To demonstrate, I will directly go to the character's BP and create a Boolean variable, leaving it as false by default, and connect it to tick only so that we can see the value of this variable. In the first row of the following columns, the names of the variables should be listed, and in front of each actor, the values of each corresponding variable. You can create variables directly through C++ and also through blueprints. However, it should be noted that float variables are not recognized by GameBalance if they have been created directly through blueprints. Now let's save the spreadsheet as a .csv and close it. In the table name section, we'll put the exact name of the spreadsheet we edited. Finally, we need a trigger for the GameBalance to work, which can be done by calling the updateProperties function from within the GameBalance GI subsystem. You can call it through C++ or through the player controller. In our example, I will call it within the character itself and say that it will be activated every time I press input B. Here within the GameBalance component, you can add an event to the updateValues delegate, in case you want to update internal functions through Blueprint. Now just hit play and press input B. If everything has worked correctly, a pop-up will appear on the screen and the values will be changed. Notice that the Boolean variable changed from false to true and the speed increased to 1200, which is the value that was in the spreadsheet. Let's do a test. Press F8 to exit game mode without ending the playback. Let's go to our spreadsheet and change the speed value to 100 and set the Boolean to false. Save, go back to the game and press F8 again to regain control of the player. Press B to activate GameBalance and see that all the information has been updated in real time multiple times. Now that you know how GameBalance works, it's just a matter of balancing your games. Oh, and GameBalance can even be reproduced in a build.